In one of the following graphs is the standard coordinate plane. The solution set to the system of inequalities shown below is shaded. Which one? So we need to find which one of these graphs corresponds to the solution set. So let's look at the first equation. So it says that x plus 2y has to be less than or equal to 6. Let's rearrange this so it looks like a y equals mx plus b type equation. So let's move the x to the other side by subtracting x from both sides. So we'll be left with 2y less than or equal to negative x plus 6. Then let's divide both sides by 2. So we'll have y is less than or equal to negative 1/2 x plus 3. So in the correct graph, there needs to be a line, and the region underneath this line, the line y equals negative 1/2 x plus 3, needs to be shaded. So it needs to include the line and be the region below the line. And this line has a negative slope and a positive y-intercept. So let's find out which line this is. So this graph shows a negative slope and a positive y-intercept, so this could be correct. And the region below the graph is shaded. So we can eliminate this. But let's look at J. Here we show a line with a positive slope, but that's incorrect because we have a negative slope here in our inequality. So we could rule out J. Here, the line has a negative slope and a positive y-intercept, but since this line is dotted, it means that the line is not included in the solution. But that's incorrect because this inequality says here y is less than or equals negative 1/2 x plus 3. So the line has to be included. It needs to be a solid line. So we can eliminate G. Now K has a negative slope and a positive y-intercept, since the line touches the y-axis in the positive y-axis, and the region below the line is shaded. So this matches what we got from this first equation. So K could be correct. And then H, we have a negative slope. We're going down like this from left to right. And the y-intercept is positive, but the region above the graph is being shaded here. But the solution set is supposed to be the region below the graph, since we have a less than or equals to here. So that means we can eliminate H. So now we're left between F and K. Okay, so we have this second equation here. 3x squared is greater than 12 minus 3y. And since x and y are squared, this kind of looks like the equation for a circle. So let's make it look like that by moving everything to the other side, except for the constant. So we'll add 3y squared to both sides. So on the left side, we'll have 3x squared plus 3y squared is greater than 12. So now to make this look like the equation of a circle, let's divide both sides by 3. This will get the x and the y squareds alone. So we'll have x squared plus y squared is greater than 4. So this is the equation of our circle. Since this is a greater side, we need to shade the region outside the circle. And the circle's equation is x squared plus y squared equals 4. So this is a circle centered at the origin, because the equation of a circle is x minus h whole squared plus x minus k whole squared equals r squared. So that means, since this is just x squared and y squared, there's actually just a x minus 0 and x minus 0, y minus 0 whole squared. So the center of our circle is at 0, 0. And looking at f and k, which are the only ones left, they are both centered at the origin. We also know that the radius of our circle is 2, because this right here is equal to r squared. And so that means r has to be 2, because 2 squared equals 4. So that means that from the center to any point on the circle, the distance is 2. And we can verify that, because we know that the y-intercept of this line up here is 3, right? So that means that this line touches the y-axis at 3. So right here should be 3 on both of these graphs. And we know that the radius of our circle is 2, which means that the circle should not be above the line. And in F, we see that the circle from the center to the outer edge of the circle is above the circle right here. But that's not possible, because we know from the equation that the radius is only 2 and that the y-intercept of the line is 3. So there's no way for the circle to reach above the line. So we can eliminate F. And we see in K that the circle is below the line on the y-axis here. So this represents the solution set properly. So K is the correct answer.